afternoon, everyone. Welcome to today's session in the Tinkerpreneur Bootcamp. Week 2 is all about building products and getting started on your digital venture journey. As you do so, understanding and learning different skills that you can use to build your products is extremely important. And artificial intelligence and machine learning are probably one of those defining skills that will lead product innovation across the world. So, in today's session, joining us is a regional mentor of change, Mr. Sandeep Kupnikar, and his team members, Shyam Thakkar and Pritesh Tiwari. They'll be walking you through a case study on machine learning and artificial intelligence, and will give you ideas of how you can use these technologies and these skill sets to build your own products. So without further ado, sir, I'd like to invite you to get started with today's session.
Thank you. Thank you very much, Varya. Hello, everyone. And I trust that you all are doing well and are safe in these challenging times. So my name is Sandeep Kuperkar, and I'm co-founder CEO for DSW and also your mentor of Change Students. And we really, thank AIM team for giving us this opportunity to engage with the young minds. Okay, so guys, what we are going to deal today is with machine learning, and you all know that this is a very broad and very deep topic. And what we have done is we had tried our level best to ensure that we bring to you all the fundamental understanding what you would be needing, and also taking you through one of the use case and show you the building algorithm around that. And then we hope that with this fundamental understanding, you will able to build your digital product in this Tinkerpreneur. So as we all know, and I'm also working with almost 40-50 students as a mentor in this journey with all of you guys, and I'm seeing that you guys are doing great. You guys are building products in a very good way. You guys are much smarter than us. So I hope that whatever today we share with you, you pay an attention to that, and you can apply your human intelligence to that and build a digital product in this ATL Tinkerpreneur journey. Okay, so what we are going to share with you today, the key takeaways, what we want to you have through this session is, Pritesh, can you go to the takeaway screen, please? Okay, so the key takeaway, what we want, we are planning to share with you the fundamentals of, what is the machine learning and the fundamental difference between AI, ML, and deep learning. You might be hearing this word so often, but till today, I would tell you that when I talk in industry also, there is a lot of ambiguity in terms of understanding in these terms and linking it to the use cases or to the technology. And we are going to try today to clarify that to you so that you get the clear understanding. We are also going to, share with you some very interesting applications and use cases in day-to-day life, what you would be seeing. And second phase, what we are going to do is we are going to take a use case attendance system, and we would be taking hands-on. We'll be showcasing you how to build the algorithm. We will be introducing you to the technologies. And at the end, we would be also sharing with you how and where you can start your journey of machine learning, artificial intelligence to build your product and to build your knowledge. So this is in a nutshell what we are trying to cover today. And the walkthrough of this entire fundamentals of ML would be taken by Pritesh. Pritesh is my colleague, and he would be taking us through that entire technology fundamentals. And then Shivam would be taking the hands-on. But guys, before going there, because we have students right from 6th standard to 12th standard, I want to share with an example that when we say machine learning, what do we mean? Because many times people expect magic out of AI, ML, and deep learning. But what does it mean actually? So I would like to share with an example for my young minds here. Let's take an example. We have a girl and she wants to cross the road. She knows, we all know, when it's a green signal, we have to walk or cross the road. And when it's red, we have to stop. So let's take an instance where the signal is green. She is supposed to cross, but at that time she sees that there is a motorcycle bike. It's coming in a very fast speed in the same direction. Immediately she applies the human intelligence. While the signal is green, she does not cross, she stops, because she knows over a period of this many years, she has gathered through the human intelligence that whether it is a bike, whether it is a car, whether it is a cycle, she knows she has to stop now. But just imagine if I ask computer to do the same thing, if I provide instruction to the computer. And how do we provide instruction to the computer? One of the way we all know is programming. We program, we tell computer what to do, and it exactly does it as per the program instruction. Suppose the same thing, if we do a programming and instruct to the computer, what would happen? It will walk, because it has instruction that signal is green, you have to walk. Now now the times have come where we are saying that we have to apply the intelligence to the machine, right? Because girl knows she has to stop even if the signal is green. But now we have to give that same intelligence in some way to the computer, that they understand even if it is a green, they have to stop. So how does? There are two ways. One is I write a program with all the if conditions. If cycle is coming, do this. If car is coming, do this. If some object is coming, do this. And with the less than 4 mile per hour, do this. More than 5 mile per hour, do this. So a lot of complexity. And then still there are chances something would be there which would completely, mess up with that program. So second way, what everybody is trying to do today is to make machine learn. And how? If I take all this condition as a data, external data, and I feed to the machine, and then we build a model through algorithms, and machine learns by itself with more and more data, and understands when they have to stop, and what kind of action they have to take. And because in this case, we are helping machine learn through data, one of the way it is called as machine learning. So we are helping machine to learn through the data, right? So this is in a very simple way I wanted to share with you. What we are going to see today is machine learning. And machine learning is a part of artificial intelligence, what I think Pritesh should be taking you through. So here I will hand it over to Pritesh, but with one note, that please pay attention to this initial 20 minutes, because these are going to set your fundamentals in a very right perspective. You need to have these fundamentals, because today, if you'll see, programming by itself is a complex thing. And we are talking about algorithms, but they walk hand in hand. So please pay attention to this 20 minutes, and then you will understand the hands-on what Shivam will be taking. Over to you, Pritesh. Thank you very much.
Great. Thank you so much, Sandeep. Am I audible first of all before I move ahead?
Yep.
Great. So, welcome, guys. A very good evening to all of you, and thank you so much for joining today. And as Sandeep has already set the context, he has already walked you through what exactly we're gonna cover today. So I will just give you a brief on top of it. So we'll be covering various aspects of AI, machine learning, and deep learning. We will, with the short duration of time, considering the time limit, we will just try to explain you what are the various components of artificial intelligence, machine learning, deep learning, what exactly tools which are required to become a data scientist, or which have been used in day-to-day life while you are working or doing any machine learning or data science project. Okay, and then we will walk you through the introduction of machine learning, and then we will have our hands-on session on one of the use cases that we're going to talk about. Okay, so as Sandeep said, I would like you to pay attention to this next 20-25 minutes while we have the walkthrough of this entire session, and please feel free to ask any questions. So Team Atal, like if anybody is having any questions, they can, I believe they can put it over the chat and they can ask. And please feel free to interrupt me so that I can take those questions accordingly.
Yeah, absolutely. We're keeping an eye out on questions on YouTube. As and when they come, I will bring them on. Thank you.
Great, thank you so much. Yeah. So yeah, insights on data growth. First of all, I would like to tell you what exactly, like why exactly data science is required before moving ahead with the data science, what exactly machine learning is, artificial intelligence is, what are the various applications of it. First, let's understand what exactly, why it is required and why everybody is using data science nowadays. So I would just give you 10 seconds, just observe this image carefully and just try to, grasp whatever information you can from this particular image. Then I'll talk about it. So I believe you just had a glance on it. So I would just add some more information. Everything is visible in this image. I believe you have understood what exactly I'm trying to say over here, but I would just give you a small walkthrough on this. So basically, this data was collected by Laurie Lewis, which actually talks about what actually happens, in one particular internet minute. One internet minute, it just one basically 60 seconds, and basically it can pass while you are just scrolling Facebook, Instagram, talking with your friend, drinking water or something. So that is one single minute, and in that one single minute you can see that 69 million messages are being sent on WhatsApp. We on daily basis use WhatsApp, Messenger, LinkedIn, Snapchat, right? So in that one single minute, approximately 197 emails are being sent across the world. 3 point, I would say 3.4 million Snapchats are being created in one single minute, and this data is really huge. And to process this data, when I say process, you are sending messages, right? You are sending data to your friend, but these companies needs to make use of that data and create machine learning models on top of it, so that it can make sense to the business. I believe it can make, various use cases. So that is the reason the use of data science, use of machine learning, artificial intelligence is so really important. And we will see in further slides how exactly it has been done and what are the various components of it. So we'll start with key essential skills which are required to deal with such a huge amount of data and to basically work in any data science project or the project you will be working on. So what are the various key component skills which is required, and you should acquire these skills to clear off this project easily. So when I say data science is combination of multiple skills: computer science, machine learning, mathematics, software development, traditional research, and domain knowledge. So when I say computer science, it is like various programming languages which are there in the market. So if I say, as per the Forbes, there are more than 196 programming languages across the world which has been used into the software development and in the IT. If you see on the top, there is always Java, you have Python, you have C, C++, R. But in a data science, there are multiple programming languages which has been used widely, and Python and R are on top of it. And I believe all you guys already had an introduction on Python and did a small workshop on it. And even today's session, which we are taking, the example use case that we'll be teaching you is of course on Python as well. So learning the programming language and implementing whatever you have learned is a part of computer science part of that particular data science. Understanding mathematics and statistics is also really important. You don't need to be a mathematician, or you don't need to be a statistician to become a data scientist, but you should know the core of mathematics. When I say the core of mathematics, what do you need to know? You need to know the basics of linear algebra, you need to know the basics of calculus, and in statistics you need to know the basics of statistics, not getting deeper into it, but you should know various kind of normalizations, you should know various kind of theorems which is there to see the distribution of data. And you should know two different types of statistics, which is descriptive statistics, inferential statistics. We will also talk about in detail in the further slides. Then the third part of it, software development. So how computer science is different from software development is, when I say computer science, I'm considering the only the programming languages and the basics fundamentals of programming. When I say software development, so it is end-to-end life cycle of any software. When you are creating any machine learning model, you are not just creating a model, you are working on a particular business use case, and that business use case needs to make sense at the end, so that that particular model can be stitched to any software, or it can be stitched to a journey of a business where it can be utilized. So the important component of data science is to understand how exactly software development happens. So for that, you need to understand the various components of software development life cycle, which is uh, gathering the data information, then doing the development, putting the development in the UAT, putting that into the production, doing the testing, and a lot of stuffs. So that is really important. Important part of data science, having the mindset of software developer while you are developing any model. Because being a data scientist, your job would be to just deal with the data. You have nothing to do with the software. You will have to create an APIs at the end that will be provided to the software engineers who create softwares. But if you have the mindset of them, if you know their job as well, what exactly they are doing, so you can make their life easy by creating a component that can be usually used by them as well. Okay. And the next part is domain knowledge. So domain is something, the business. For example, if I'm working for banking, I should know how banking works. If I work for insurance, I know how should insurance work. If I'm working for any, you buy pizza, you buy online stuff from any from Amazon or Flipkart. So these are the e-commerce companies. So if I'm working for an e-commerce company, I should know the business of e-commerce, like how exactly it has been executed, how the data is coming, how the models have been built, and how it is benefiting my customer and my company as well. So that domain knowledge is also really important when you want to become a data scientist or when you're working on any data science project. Okay. And the last part is traditional research. When I say traditional research, it's like, for creating any machine learning algorithm, you need to do a lot of research. For example, there are multiple machine learning algorithms available, but you cannot utilize or cannot use any machine learning as and when. You need to understand which machine learning or which algorithm is important on what kind of data, on what kind of business problem statement. Based on that, you utilize it. Secondly, machine learning development is on very fast advancement. There are a lot of libraries which is getting added day by day and week by week, I would say. If you're using a particular library today, that might become not that much relevant or useful a year later. So it is really important for a data scientist to keep their knowledge updated, to keep on doing the research on that particular area which they are very much keen with, or on the project on which they are working. If I'm working on facial recognition, so I should know what are the various libraries which are available in the market, which people are using to create a system for facial recognition. There might be 10, there might be 20, and based on the business understanding, I might be using two of it. But these two I should know in deeper into it, and if there are any advancement into it in future, I should know that as well. That is the reason traditional research is really important as a part of data scientist job. Sorry. So saying again, if you have any questions, please feel free to ask to Atal team and they can bring it over to me. Yeah. So again, talking about few key essential skills. So we already saw what are the various in general data science skill sets. So this is having the mindset. I'm not saying these are the key essential skill set from the from the technology perspective, from the technical perspective, but these are few of the things that you should know as a data scientist while working on any data science project. And these are few of the tools that will key essential skills that we'll be looking into, which is really important. As first of all, being curious and excellent communicator while working on any data science project. You should be curious to know that I'm working on what kind of data, and this data is really suitable for this particular algorithm which I'm going to use or not. Because unless and until you are curious, you are just following any tutorial on the net, you are not able to create a prototype or a model which can be actually be useful. You need to be curious to know about the data that you have in place. You need to be curious to know whether this model that I am going to create is accurate enough so that it can have an impact on the business or not. So that curiosity, it needs to be there. And once you are curiosity, there needs to be, you need to be an excellent communicator first of all. Okay, so we can go ahead. So as we saw over here, you can see I was talking about mathematics and statistics, and inside statistics, what important components are descriptive statistics and inferential statistics. Okay, so just to give you an example, what does it mean? So descriptive statistics is something like analyzing the data which is there in front of you, okay, and creating charts or giving some information out of it. It is called the descriptive statistics, or also including the historical data as well. So you're not making any predictions. You're just utilizing the present data, you're just utilizing the historical data, and you're creating some use cases. You're giving some insights out of it. Let me take an example. If I am selling a school bag, okay, and I have a data from previous year, I have a data from 2017, 18, 19, and 20. Okay, so in the descriptive statistics, what I will say that, okay, in 2017 we made a business of X number, in 2018 we made a business of X plus 1, in 2019 we make a business of X. So this is what descriptive statistics is all about. The next one is inferential statistics. This is one level advance of descriptive statistics. Here, what you do, by considering all the historical data which you have plus the present data, you predict future. You try to provide, you try to forecast what exactly going to happen in future. For example, if I am a school bag seller and I know that I have a data of 2017, 18, 19, and 20, and I know that in 2017 I did X amount of business, in 2019 I did X amount of business, in 2020 I did X amount of business. So how much business I can do in 2021? Based on that, I can be prepared. Like I'll be preparing myself so that I can stock those number of bags, and by considering the various other things, I'll be prepared to take over my business for the year 2021. So in very short, descriptive statistics deals with historical data and present data and talks about what is happening inside that data. Inferential statistics is all about considering the historical data, considering the present data, and talking about what is going to happen in the future. So that is inferential statistics. The next one is programming languages. As we already talked about, as I said, that there are more than 196 programming languages, but 196 programming language is something that has been utilized across the globe in various IT projects inside the IT sector, I would say. But for data science, from the data science perspective, R, Python, and Java, these are the most important programming languages which has been used. So if you are doing any research in statistical side, or if you're creating any prototypes of machine learning models, you usually go ahead with R programming language. If you're working on any machine learning problem statement, or any deep learning artificial intelligence problem statement like what we're going to see today, we usually use Python for that. And Java is basically, again, Python and Java can be used together. So but it has been observed that for majority of the big data project, like for Hadoop and PySpark, as the backend engine is written inside the Java, that is the reason Java also becomes a really core important programming languages while dealing with it. So if I say, if you want to become a good data scientist, which programming languages you should know very well is R, Python, and Java. So if you learn, you should learn all three of this, but should be proficient, highly proficient in at least one of this, because at the end programming languages is just a combination of various syntax. The most important thing is logic building. You need to increase your logic building power. Going ahead with the databases, so we have SQL, we have NoSQL, and we have graph databases. So what is SQL database? SQL is very structured data, like you might have seen the Excel. So Excel, you see that you have collection of rows and columns, right? So whenever you see those kind of data, that is structured data. So for that, we are using two different type of databases, MS SQL and PostgreSQL. We can talk deeper into it, but given the time, I'm just giving you the glimpse, like what are the various databases that has been used. For the NoSQL, whenever your data is not very structured and it is not in the form of rows and tables. For example, if you comment on Facebook, if you're tweeting, or if you're providing comments on Instagram photographs, so those are all textual data. It cannot be stored in the form of rows and columns. Those needs to be stored in the form of trees and structures, that is easily been possible with the help of MongoDB. So those are called NoSQL databases, and MongoDB is one of the widely used. Graphical data is basically, you have two different things into it. You have GraphQL and Neo4j. What are the graph database? So when I'm talking about SQL databases, you have a data model, or I would say you have multiple databases, multiple tables. So to provide a relation among all these tables, how the data is flowing from one table to another table, how the data is flowing from one database to another database, you use a graphical representation of connectivity of those data, which has been represented in Neo4j and GraphQL. Okay, so let's move ahead. Understanding algorithm understanding and getting deeper into it. So yeah, so now we come to machine learning. So before coming back to machine learning, let's first understand what exactly algorithms are. So when I say algorithm, it's just collection of rules. So as Sandeep said, Sandeep was giving an example of a girl crossing the road. So what are the various rules you follow when you're crossing the road? You just look left, you just look right, and then you look at the the lights, whether it is green, yellow, or it is red. And then if it is green, you will first look right, then again left, and then you will cross. So these are few of the rules that you follow while crossing the road. So all these rules, when you collect them together, okay, when you bind them together and make a particular function, it can be called as an algorithm. Okay, so what is the basic difference between algorithm and machine learning algorithm is, to create any algorithm, you need to define all the rules, so that to cross the road, you need to look at the bulb, you need to look at left, look at right, and then cross the road. So you need to explicitly define the rules. Okay, then only the outcome will come. But during machine learning model, you don't need to define the rule. You just need to provide the input data. What can be the input data? That I want to cross the road. And the output data. Output data is like, okay, I want to go that part. So all the rules which is which needs to be done, it has been automatically been created by the machine learning algorithm. I will provide another example when we get deeper into machine learning on the very next slide. So there are various types of machine learning algorithms. We have supervised machine learning, we have unsupervised machine learning algorithm. In supervised machine learning algorithm, like if you like we have linear machine learning algorithm, we have logistic, we have random forest. When you're dealing with any continuous data, you usually take care of use linear algorithm. When you're working on any classification like problem statement or classification type of data, you use logistic regression. When you're working on, like sometimes when you're working on very hybrid kind of data where you have combination of all those things, so there are multiple algorithms which can be used on top of it, but random forest is of course one of them. So just to take an example, we have written random forest. Now talking about unsupervised algorithms. So as I said, for machine learning, for supervised algorithm, you need to provide the label. Label means the outcome and the input data. But in unsupervised, you don't need to provide the outcome. You can just provide the data, and data itself will identify whether it will identify the rules, and it will kind of create the clusters for you, clusters of the data on top of it, which you can apply again supervised algorithm to have the better understanding of it. So I have a visual representation of it. I will show you on the next slide that will have a more clear picture on it. Again, this was the from machine learning perspective, these are few of the things that you should know: supervised, unsupervised, inside supervised linear logistic, inside unsupervised clustering. And then you have deep learning. Inside deep learning, there are again different kind of architectures. You have ANN, you have for dealing with images, you have CNN, convolutional neural network. For dealing with text data, you have LSTM and RNN. So these are few of the architectures which you used in deep learning. Talking about the technologies which are really important. So we already talked about the programming languages, and talking about the big data architectures or big data tools which is required and you should know as a data scientist is Hadoop and Spark. And in today's time, like there are a lot of APIs which has been available, which can be easily used by data scientists to create any machine learning task or to deploy any machine learning algorithm which you are creating you need to be aware of cloud services. At least you should be proficient in either one of them. It can be AWS, it can be Microsoft Azure, it can be GCP, or if it can be others as well, but you should know the fundamentals of cloud computing, how you will create any machine learning algorithm, or how you're going to deploy it on one of the cloud providers. So that is really important. So machine learning tools, get started with machine learning, what are the various key important tools that is needed? The first one is Spider. I'm sure you are already aware of it, but if you're not, you can just install Anaconda on your laptop. That will provide you all of these tools: Spider, Jupyter Notebook, Anaconda, and Google Colab. So these are nothing but the IDEs, or a platform required to do the programming of Python. If you want to create any machine learning algorithm, how you gonna do it? With the help of Python programming. But where you gonna type all these things? On one of the IDE platform. These are the IDE platform that you can use. And for today's session, we're gonna use Google Colab. AI versus ML versus deep learning. As Sandeep was talking about, there are a lot of words which is happening across deep learning, machine learning, artificial intelligence. So just to clear how exactly and what exactly it is, so let me just give you an example. So basically, deep learning is a subset of machine learning only, and which is highly inspired again by artificial intelligence, or we can start from the top. Artificial intelligence. So AI is on the top, and machine learning and deep learning are part of it. So you can say that AI is something like, or it has been inspired by human brain. As Sandeep was talking, like when a girl is crossing the road, she is taking decision because she is human. She can see what is happening in front of her, and based on that she can take the decision. But when you want to train a computer, you can train it with the example of examples and logic, but that can be done with the help of machine learning. But to provide some deeper understanding, to provide some human level logics to it, you usually use artificial intelligence. And inside artificial intelligence only, you have machine learning and deep learning. We already talked about machine learning. It's creating a framework where you are just providing the input data and the output data, and the logics and the rules is been explicitly created by the algorithm. You don't need to define various logic, that if a plus b is equal to c, then this a plus b you don't need to define. You just need to provide c, which is the output, and you need to provide a and b, and the machine itself will identify that a plus b becomes c. This is the logic that has been uh, explicitly identified by the machine without you telling it. Okay. And deep learning again will, like for working on artificial intelligence, as I said, you need to create a human like uh, framework, or I would say something intelligent machine learning or intelligent system which can have the understanding of human like brain functioning. So for this, deep learning has been used. How much time we have? Yeah. So introduction to machine learning, I'll just quickly hop on this. So we already talked about it. So as I said, for machine learning, you just need to provide the data and the program. Program is like you don't need to provide the rules. This is the traditional programming. Here you need to provide the data. And when I say program, it is all the rules. That data is A and B, and the program or the rules is A plus B, and it will provide you the output that A plus B is C. But for machine learning, you need to provide A and B, and you need to provide C, and the computer will itself create it all the logic, and it will understand that whenever you provide A and B, it is going to always give you C. Okay, so you just provide data, you just provide the output, it itself defines all the logics which is going to go inside machine learning. This is an example. As you can see, this is a human. It is telling the machine that this is a dinosaur, and when but this image is exactly a bit different from the next dinosaur. but it has not been trained by this particular machine learning. But next time when it this particular new image has been given to this machine learning, it can identify that it is a dinosaur because of the features of this dinosaur, like two small hands, two big legs, one big tail, and this kind of face. This makes it a dinosaur. So these are the features, these are the rules that has been created or generated by the machine learning algorithm on its own. Okay, so these are the various like steps which is been done in the machine learning development life cycle. You need to understand the requirement, you need to understand the data. The third step is like by after understanding the requirement, after understanding the data, you create the machine learning model. Then you basically test your model, how good it is performing, and if the performance is good, based on the various evaluation metric that you're going to use to test the accuracy of your model, then you deploy your model. And finally, after deploying it, if there are new changes in the data that you will be bringing in future, you are going to do the optimization of your model. And then finally, once everything is ready, you will connect to the applications. So various types of machine learning, we already saw: supervised machine learning, unsupervised machine learning, and reinforcement learning. So I already talked about supervised and unsupervised. I will talk about reinforcement learning. But just to give you a glimpse in a short, this is the input data. These are the annotation, that is the rules that we are telling supervised machine learning algorithm that this is the input data and this is the output, that it is an apple. So next time when you give a new data or a new image, it is explicitly telling you that it is an apple, because it has been trained by this machine learning algorithm. Now it knows that whenever a feature or whenever an image which comes like this, which has a small leaves or this kind of like red color or this kind of a feature, it is an apple. And for the unsupervised learning, you don't know the output. So it's like you are just providing the input data based on its own understanding. It is defining that, okay, all these features which has dark red color, a small leaves, it is going to be one single cluster. And all images which is orange in color and have a small leaf, it is going to one cluster. And all the features images which look like this, it is going to be a banana. So it has created the cluster on its own without you providing explicitly or telling that which data points belongs to which cluster. Reinforcement learning is a third type of learning, as I mentioned. So it is basically based on two things, which is punishment and reward. So when I say punishment and reward, it's like it's again a rule based algorithm that sees that how it wants to move further, and it will move further based on either reward or the punishment. For example, consider two scenarios. The first scenario is fire plus a child. So when a child approaches the fire, it feels warm, and he understands that fire is a positive thing, it's a reward. Similarly, on the second hand, you can see that the child, instead of approaching the fire, it touches the fire, and it observed that it is not a reward, it is punishment. And the learning from that is touching fire is a negative thing. Okay, so it's a conclusive based learning where, based on either reward or based on the punishment, this algorithm understand that what next step it needs to take. So it has been basically used a lot in uh, uh, driverless cars. Well, you might have heard about Tesla and all, so they are using reinforcement learning in the back end a lot. So some interesting applications. I believe we are short on time, so I will share the link with Atal team, and they can just pin it. So next time, whenever you are available, you can just have a look into it. And so technology used into it is like, once you go through the video, you can come back to this to have a look. The technologies which has been used into it is facial recognition, object detection, emotion analysis. I will just give you a small brief on each of it. Facial recognition is the use case that we are going to see today. Okay, so I believe Shivam will talk more into it. Object detection is something like, as a human, if you see in your room, you can see a laptop, you can see a bottle, you can see a cup, you can see a mobile phone. You can identify this object because your brain has been trained that when object look like this, it is a bottle. When object look like this, it is a cup. When object look like this, it is a mobile phone, right? So that is object detection. Emotion analysis is understanding what is the emotion of a person. For example, if I am crying, you can understand I am crying because you have seen hundreds of people crying, and you know when to call a person is crying, when to call a person is smiling, when to call a person is, is worry, is not happy, or he is sad. So that is something called as an emotion analysis, which these three use cases have been stitched together to create the entire use case of the previous video, Amazon Go video, which I was talking about. So this is the object detection example. See, the camera itself can identify that this is a car, again, this is a car, this is a traffic light, this is a person which is there in pink color, this is a bicycle. So it can identify all the object which is there in the image. The next one is virtual assistant. I'm sure you might be interacting with a lot of virtual assistants in day-to-day life. You might be aware of either Siri, or on your, you might be doing Hello Google and talking to various stuffs on your mobile phone. So again, there is a machine learning which has been used in the backend. It can understand your command, it can understand your language, translate it into the machine language, do all the processing, bring out the results to you. It is happening with the help of machine learning. So what are the various use cases that you can see into day-to-day life, or what are the various things that this kind of voice-based applications are helping you to? It is basically providing various kind of weather reports. It can help you to help you with real-time news which is happening. You can connect various devices, you can unlock your doors, and these are few of the examples which are happening with virtual assistants, voice-based virtual assistants, I would say. And the technology which is being used in the back end of it is natural language processing and speech recognition. So I already talked about object detection, I talked about emotion analysis, I talked about facial recognition. So these are a few of the things that you do with image data. But when you're dealing with voice data, when you're dealing with text data, so the backend technology which you make use of it is natural language processing and speech recognition. Yeah, so I believe I'm good with it, and further we will have a hands-on session on one of the use case, this one which I was talking about, facial detection, facial detection and then recognition, which will talk about recognizing a face of a person. That we will show you how to implement that end to end. So that will be taken care by my colleague Shivam. So Shivam, maybe you can get started.
Yeah, okay. Thanks, Pritesh. So, can you give me the access to share the screen so I will get
Yeah, I'm
started?
stopping the share and you can stop.
So, yeah, hi everyone. We'll be starting with the hands-on part. So, considering the time aspect, we'll try to run through this notebook, and eventually this link will be provided to you guys. So you can come back and run through this whole thing again and try to understand it. And this code will be already available to you guys. So if you want to customize it in some extent, you can do that also. Okay. So firstly, I would like to tell you what environment we are using. Here you can see we are using the Google Colab. So if you just want to land on Google Colab, you can just search Google Colab and you will be taken to this particular link wherein you can start your own notebook. You can create a new notebook, and that is where you will get your own notebook. Okay. So this is built on top of Google Colab, and you will see here there are two different types of blocks. One is code and one is text. So whenever you write some code, you can execute it in that block. And if you want to uh, have some title, also maybe you need to write some sort of explanations, definitions, you can add in terms of text. So that is how it works. Okay. And here you can see there are two different type of blocks again. One is text blocks and one is whenever I wanted some code, there is this code blocks we have used. So here we have divided it into step-by-step process. Firstly, you can say this is how we set up the environment. Firstly, we set up a GPU environment. GPU, why? Because the workloads are heavier when it comes to machine learning. and you will have to have a GPU environment. And this is a good free service where you can actually train your models, do machine learning practicing on Colab without it is a, you can say it is a free service. There is a paid service available, but I don't think so at this particular time you will require that sort of service. A simple workloads can already be handled by Google Colab's free service. So this is the step you can say enable GPU. Just click on runtime, change the runtime type, and select GPU. Okay, I have already selected, so it is reflecting here, and you click save button. So now you are on a GPU. Okay. The second is installing a face recognition library. So when it comes to library, what happens is there are some modules, some functionalities been already built, which has been published as open source, right? So you can reuse it. That's what the library means. You install a library, try to reuse this functionalities. Okay, so here we have a face recognition library already been published as an open source. So that is what we are trying to install inside Python environment. So to run the cell, you write whatever the code you want and you press shift enter. Okay, so it will run and install the required library for us. So it is pip install face underscore recognition. The name of the library is face underscore recognition, and pip install is the command. Okay, so it will install the library for us. And while it is installing the library, let's go to the next step. So what next step is, uh, let's upload some of the dependencies. Dependencies in the sense we require some data. Okay, and for displaying we require some fonts. So these are the two dependencies we require that we need to upload to this particular environment. So I have created a drive link. So whenever you guys want to run through this particular piece of code, just go to this drive link. Okay, and you will see there are three files that you need to download, and then again you will have to upload it to this particular runtime. Okay, so you click this particular files button, you will reach here, and now you can actually upload to your session storage. Okay, so when you click this, wherever you have downloaded this stuff, you can go to that particular directory and just select those files and click open. Okay, so what it was saying is whenever this runtime is disconnected, your files will be deleted. So as I said, it's a free service and there are some constraints. So whenever your internet is connected, the files will stay. Whenever your runtime is there, the files will stay. Once there is some sort of disconnect, the files will be deleted. Okay, so that you need to take care. So if you are disconnected, maybe you will have to upload it once again. Okay, so now what we are trying to do here is we will be unzipping the data. Zip, these are the zip files. So now we want to unzip so that all the images, here we are dealing with images because face recognition, as you can understand, there will be some sort of facial image over which our algorithm will be trained, and then eventually our major task will be to recognize as the new image comes in. Okay, so this images will be unzipped. These are the commands that will be used: unzip the train, you can say zip, and unzip the test zip. So again, the data is divided between two different folders: train and test. So train, as you can understand, it will be used to train the algorithm. It will be, as we have understood, there are two types of learning: supervised and unsupervised. This you can see as a supervised learning. Now we have the image, as well as we will have the labels, that this particular image is of this particular celebrity. Okay, and then that tags as well as the images will be fed to the algorithm so that it learns. Now if this type of image comes in, I should understand that this is for Barack Obama, this is for Elon Musk, whatever. You can also train on your images. That's not an issue. Okay, this will be available to you guys. So whenever you want to add new data, what you can do is after unzipping, you can actually insert more images you want. For example, you want to create attendance system for your class. So what you need to do is just collect images of all the individuals in your class and feed into the train folder. Okay, that's what you need to do. Okay, and automatically this algorithm, this particular repository is built in such a way that it will consider all the images in the train folder while training. So how you give the labels? Whosoever the image is, just try to name it with that particular individual's name. So here you can see this image is of Barack Obama. So I have named it Barack Obama.jpg. So that is what you need to also follow. Whatever the individual or roll number you want to put, okay, of your class, so you can name it as 1.jpg. So whenever the recognition takes place, it will recognize as 1, 2, 3. So you can directly associate that this is the roll number. So roll number 2 is this individual. So this algorithm recognized that this images are of roll number 2, right? So that is how you can customize this particular repository. Okay. So now you can see we are importing other libraries. So that's the base module. Face recognition is our base task. Now you also require some other libraries or other important functions to do it end to end. Okay, so it's not just about passing the data directly and getting it done. There will be some sort of pre-processing required in terms of how the images will be transformed in some sense, right? And after that you may want to display the image. So for all these different functionalities you may require different set of libraries. So you need not worry about that, what library does what. Okay, you will eventually, if you are getting started with this journey today, so you will eventually learn what library is used for what purpose. So right now you need not bother about that. Just try to understand the piece of code you have and try to see how those functions are working. That will be very much good as of now. Okay, now these are the libraries that we will be importing. So let's run this piece of code. And as I mentioned, there will be some customizations required uh, in terms of reading the data, displaying the data, training the data. So these are the custom functions that we have built. So here you can see there is one function which we have built to read the image. Okay, so the major idea here while reading the image was to set a you can say default width to 500 pixels. Okay, because what happens is if there is some irregularity in the different images, the training algorithm might suffer issues. So it's a good practice to have data in some normalized form. So as we were discussing on the slides, there is some sort of normalization always required for the data. So here what normalization we are targeting is the width to be always 500. Okay, so the relativeness is now set to 500. So something above and below 500 will actually cause an issue for the algorithm. So we will come to a standard format, that is 500 with images. Okay, that is what we are trying to do here. So if you would have learned Python, you can say this is a function definition, right? So we are defining a function and we are writing all the sets of you can say instructions inside the function. So whenever you feed the path of that image, it will read that image, it will do the required standardization, and it will return the new image. Okay, that you can directly feed to the training algorithm. That is what we are trying to do here. Okay, so now when you see training, okay, now again I'll tell you, don't get distracted or don't think that this is going more and more complex in terms of code. You need not worry about that right now. Just understand we have defined the title also. So this block is particularly for training. Okay, and as I explained you, if you want to reuse, don't mess up with the code. Just try to change the labels inside the test folder, train folder. That is what you will be able to do and easily customize to your particular images. Okay, and when it comes to understanding the code, basic understanding will be clear now, but if you deep dive and try to learn more about Python logics, you will get to understand what exactly the code is about. Okay, but there are also comments provided so that you guys get clarity of what exactly this line of code or block of code is trying to do here. Okay, So for particularly this block of code, let me just try to explain you. But going ahead, I'll leave it up to you guys to you can say decode the comments and try to understand what exactly the code is about. So here you can see list to store image encodings. So image encodings. Now something new here. Encodings. What are encodings? So now you need to understand. Computers cannot directly understand the image data. Okay. You will have to bring it in a certain format that is easily understood by the computers. So the most basic format is integers, set of integers. So when we say encodings or embeddings, those are nothing but integer values given to a facial image. Okay, here you can see I have illustrated one example. So that is, this is what happening here. When you give a new face to training model, it will generate an encoding. So what encoding is? Series of integers, and these are not random. Okay, just try to understand. This trained model is trained in such a way. I'll try to tell you right now what model we are using is not actually from scratch. It is partially trained anyways. Okay, so which means it has been fed with lot of images earlier, so that now it is able to differentiate, okay, at some sense, using the basic features. Okay, as we have saw in the slides, the basic features of uh, dinosaur was the tail, the legs, the face part, right? So now using these basic features of face, what is the shape of nose, what is your width of mouth, right? What is the height of your forehead? So using these basic features, it will be able to generate a numeric encoding. Okay. And now this encoding is representation of that actual facial image, right? So this is what the face embedding is. So get this clarity in your head that directly you cannot deal with face, you can say image data, but you will have to bring it into some format that can be well understood by the computer. So this is what we are doing here, generating a facial encoding, or you can say image encoding. Okay, and now labels are nothing but the file names. So now we are preparing the data, we are generating the encodings, and we are assigning the labels. So now your data is getting prepared to get trained. Okay, so now we are iterating through whole folder and doing the same process, reading the image, generating the encoding, and appending the labels, right? So this is your training, you can say, function, which is doing our data preparation. And as I suggested, we are using a pre-trained model, so there is not much of training which will be required. Just pass on, generate the embedding, and store. That is what our training part will be for this particular algorithm. This will differ from algorithm to algorithm, so it's not a general thing, but yes, for this one, this is how it goes. Okay, so now what we are doing is we are running this particular function, right? And we are giving the folder name. This is the folder name. So as I suggested, you just change the images in this folder and run this function again. It will automatically train on your custom images, right? So once this training is done, you will get different encodings and labels for that particular set of images you have. Okay, and now this is the inference part. Now you can see here, the inference is nothing but now you have the model ready. Now you just need to pass the new image, get the encoding, and then see how near it is to the existing faces. Okay, now just try to understand. When we transformed it to an encoding, it was a numerical representation. Okay, and now just get back to a mathematical representation. So some of you guys, if you are in you can say higher standards, 10th, 11th, 12th, you guys can relate the Euclidean distance, or you can say when you see something on graph, it will be made up of two you can say dimensions. Right now, if you can visualize on a two-dimensional graph, it will be x and y coordinate. Okay, and so that is what we are doing. It is not just two dimensions, it is maybe 128 dimensions, 200 dimensions, whatever it is. But the idea here is to get the difference between the 2 points. So if you just try to see it on a two-dimensional graph, this is what it looks like. Okay, so this is your original face. Okay, and now if the embedding of phase 1 is generated and it is sitting here with some x value and some y value, it is this far from the original. Okay, 0.32. The phase 2 with some x coordinate and y coordinate is sitting here and it is this far from this, so from this original phase, right? So the phase which is very near to the original is our recognized phase. Okay, so that is how this is working. You need to understand this one. And how we are calculating the distance is the Euclidean distance formula that you would have seen in your higher standards. Also 10th, 11th, 12th people can relate. Maybe the lower standards maybe need to understand more on this. So this is how it works. So x coordinate and y coordinate is there for this particular phase, and again for the different phase. So when you want to calculate the distance, you use this formula. It is that simple. Okay, so you calculate the distance and the most lower one is your answer, right? This we are discussing the internal working, and if you are getting you can say complex here, so I'll say skip this part. Just try to understand how the titles are and how the code is running, and you can make use of it. Okay, but if you are trying to get into the mathematical aspect of how the algorithm is working, this is how it works. Okay, so again, that is how this inference thing is built. This inference function is built. So if you just take a new image and pass it to this infer function, you will get the prediction. Okay, so it says the Barack Obama image is 0.38 distance, at a 0.38 distance, and this is your the final phase that has been recognized. Okay, so you will see here how it is displayed. Here you can see here. So I just passed the image to our trained. So here you can see the test image. We have some examples, right? Barack Obama, Bill Gates, Elon Musk, and one more car image is there. So I trained on these three images, and now I passed on a new Barack Obama image, and the algorithm was telling us this is the nearest uh, face and this is the smallest distance. Okay, so if you can relate it with this particular figure, you can say F1 was Barack Obama and maybe F2 and F3 was Bill Gates and Elon Musk. So now the smallest distance was 0.32. So it said that F1 is your original recognition and with the least distance of 0.38, right? So this is how it is internally working. Okay. So let's not go with how it works with multiple faces. Here again, the concept of centroid comes in. So whenever there are multiple faces of an individual, you calculate the centroid, and whenever you want to see which is the nearest image, you directly calculate the distance with the centroid. Okay, if you want to have a deeper dive, you can come to this notebook and go again, and I have explained the centroid formula also, so that you can again go if you want to do, right? And this is again just a function to display the image and show you the, you can say, scores, right? So we passed on only this image, right? What it did was it calculated the nearest face. It showed us what the face is. It typed Barack Obama and also gave us this is the distance 0.38. So it is the nearest face which I was able to found, and it also shows facial landmarks. Facial landmarks in the sense you can see it was able to detect where the jaw was, where the mouth was, right? This again can be used for different type of functionalities. If you want to detect what is the orientation of face, if you want to do the emotion analysis as we saw in one of the slides, this again the facial features thing can be used. Okay, and one more thing I wanted to illustrate is you can see there is this no face found. So it can happen. You trained on some facial images, but now while predicting, there are some images you pass which do not actually have faces. So here you don't want your algorithm to perform badly. So we put an exception in a sense that whenever you see there is no face in the image, just return with no face found and don't go and find the nearest distance, right? So that is what we explicitly code and write. So that particular implementation you can find here. If the encodings length of encodings is 0, which means you are not able to find any face in the image, just return with no face found and stop here, right? That is how it is working. So anyone having any gaps, or if you want to go more on a particular topic, you can let me know here. But basically, this is how it works, and this is the link which we'll be sharing to you guys, and you can actually run at your end and try to understand. Okay.
So guys, any question? This notebook link already has been shared in chat. If you'll see, you can use it at your end, and you can try your own code into that as well. So any specific questions here, please let us know. You see, this is a little bit complex topic, so don't worry about the complexity. In 1 hour's time or 1 hour 15 minutes time, we had tried to make it, as much as tangible to understand for students at the range of standard 6 to 12. I think this will really help you, but you will have to study further. And this, you can try building your digital products through this. You can use various use cases. Do you want to add something, Shivam and Pritesh here, how they start and, because I think it's already 5:40.
Yeah, so actually, we can quickly go through if you guys want to get started. Some of the pointers we have mentioned that you can actually get started. So first thing was the Python that we will recommend from our end, because we discussed like R, Python, and Java are three different languages you can start with. But why Python? Because some sort of statistical analysis which you can do in R can also be done in Python, and the backend which you want can also be built in Python. And the flexibility it gives in terms of different libraries available, right, is so much in Python. So when you want to get started, you can easily do it. So as we saw here, the face recognition was just few lines of code after installing the face recognition library. So tomorrow, if you want to do some object detection, there will be a simple object detection library available that you can install and get started. Okay, so that is where you can get started using Python. And again, when you will be able to quickly code some logic after you try to practice those logic solving and problem solving. Okay, so for that, we'll recommend you can use platforms like HackerRank, you can say CodeVita, right? And these are some sort of platforms that you can use. Okay, where you can go and try to practice your Python programming or C++ programming or whatever. These platforms provide this sort of functionalities, right? And as we suggested earlier also, that there are a lot of evolving stuff happening in this field. Today something is there, after a year that it won't be so much useful. Today face recognition algorithm came. After 45 days, a new algorithm comes that has much more accuracy. So you will have to keep yourself updated, right? And the last and most important one, you should not stop being curious. Why? Because here you are trying to solve some interesting problems. So there will be some different ways to solve it. And if you stop being curious and stop exploring those possibilities, it will be very difficult, because it will become a simple monotonous, just follow some blocks and implement. And if you are able to not able to find a solution to that, then again you will stop. But at this point, if you are curious, you will refer some other blogs, you will refer some other ways to do it, and you will be able to solve it, right? So don't stop being curious. And as I suggested, you should not stop staying in touch with ML and AI because it is very much evolving. So here I will try to follow some ways you can do it. First one is, anyways, you follow AI news. So you can see the third point. There are some newsletters that you can follow so that you keep in touch with ML and AI. So here are some of the newsletters. It is written in very simple, plain English. Maybe there are some technical words that you will come across, but that is actually good. What you can do is use this technical word, go to Google, write that word, try to understand what the technical word is about, and you will get more clarity, right? Maybe first two reads may not be much simple, but after three, fourth, fifth read, it will become simpler for you. Okay. So these are some newsletters you can follow. And if you guys use Reddit, then these are some subreddits you can follow. And anyways, you can always follow data science wizards, social media channels, Instagram and LinkedIn majorly, because what we do, we push different stuff on our this channels. It is in a simple, you can say, English and with very good illustrations, so that the explanations are sent very easily to the reader, right? So that also is one thing that you can do.
Yeah, I just went in terms of questions, I just went through all the chats and I think we've pretty much covered everything. Just for the students who've put in, you can access the link that's pinned on the YouTube chat to go through all the code and details mentioned in today's session. If you want to go through the platforms that were referred to, you can just rewind the recording and go back to that. It's already there. And after this, if you still have questions, you can send them to your mentors and they can forward it to us, so that we can get Sandeep sir and his team to give you specific answers to your questions. But I think for today's session, you've got a complete overview of, just a theoretical understanding of the subject as well as a practical application. And I think after this session, we would strongly urge all of you to think about the products and the digital ventures you like to build, and if machine learning is something that should feature in that. And if yes, please go back to this session, learn the critical skills and theoretical concepts required, and get started with building your product. This week is all about getting the V1 of your product right. So once again, thank you, sir, for doing this session. It's been an absolute delight hosting you. And thank you to all the students, mentors, and ATL in charges who joined in. We will see you again in the next session.
Thank you very much.
Sure.
Yeah. Thank you.
Thank
Stay
you.
safe.
Thank you, Varya and team. Thank you, everyone. Bye-bye.
Thanks, everyone.